Welcome back, Math Marbles. This is lesson 102, applying operations with scientific notation. Now that you know all four operations, we're going to perform any of the operations, and in some cases multiple operations with numbers in scientific notation. And since many of these will be in word problems, we're going to make sure that we know how to identify what operation is being used so that we can solve them accurately. Let's explore this first problem. I've already written it out. It's a very huge number in this problem. The mass of Earth is approximately 5.972 times 10 to the 24th. That's a very large number, kilograms. And the mass of Jupiter is approximately, this number is so large I don't even know how to say it. This is me being very honest. It is well past. Matter of fact, since we sometimes think of millions, here's billions, and this is still way, way bigger than that. So we're going to have to write this down in scientific notation, absolutely. And we want to know what is the difference between the approximate masses of Earth and Jupiter. All right, so to start getting this in scientific notation, there are tons of zeros. I'm going to do some skip counting. Just so I can see the shift. So this is 3, 6, 9, 12, 15, 18, 21, 24. This would be if it was the same. 27. Okay, so now I can write this down in a more manageable number. 1.898 times 10 to the 27th power. Huge number. It's definitely bigger than Earth, which is 10 to the 24th power. So we're going to subtract 5 times 972. So visually, if your eye is looking this way and going, I can't subtract these, remember, these sizes matter for adding, subtracting. So we need to make a change. We need to make sure they are the same size. So we're going to turn this second number to times 10 to the 27th. So think for a little bit about what's happening here. If this number is, my exponent is increasing by 3, that means my second number must have decreased. I have to do 3 shifts. It has to get smaller. Has to be smaller by 10 to the 3rd power. So that means I need to shift it 3 times. So let's write in that number. I'm just going to give a little practice so I can see where the room would be. Like how much room was I'm writing these down. So here it is. I would have to go 1, 2, and 3. Okay, so I have 0.005972. And I want to give myself space because when I'm adding and subtracting, I need my numbers to be lined up. And I'm going to need some space holders here. All right, so that was the only reason why I wanted to write that there, because I wanted to make sure that everything was lined up for me to subtract. Okay. Let's do my subtraction now. I'm going to use a trade first method. Times 10 to the 27th times 10 to the 27th. All right, I'm going to use trade first, meaning I'm going to just look from the left and see if I can subtract. Yes, 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 yes. Here I cannot, so I'm going to have to regroup. So this is a 10. Now I can subtract. I can't do 0 minus 7, so I'm going to regroup. And I can't do 0 minus 2, so I'm going to regroup. All right, now I have enough that I can do all my subtraction. Again, this is the method that I teach to elementary school students that just helps them do all their borrowing first before they do any subtraction. Now I can get my answer. 10 minus 2 is 8. 9 minus 7 is 2. 9 minus 9 is 0. 7 minus 5 is 2. 9 minus 0 is 9. 8 minus 0 is 8. Decimal point 1 times 10 to the 27th power. Now I just take a second look just to do a check. And it is okay. It is in scientific notation, so I don't have to make any changes. So Here we go. Hit pause so you can jot this down into your notes. And we'll move into our next problem. Take a moment to read this problem to yourself while I read aloud. When the sun makes a full rotation around the center of the Milky Way, it travels 2.025 times 10 to the 14th kilometers. The average speed at which the sun travels is 8 times 10 to the 5th kilometers per hour. At this rate, determine the approximate number of hours it would take for the sun to travel that distance. Okay, so this is absolutely a division problem. I'm going to take the distance from the sun's rotation to the center of the Milky Way, which is 2.025 times 10 to the 14th, and I'm going to divide it by the speed of the sun. 8 times 10 to the 5th. Since we have our quotient rule here, I know that this part over here, I'm just going to do 10 to the 14 minus 5 since I'm dividing, and that means I'm just going to have 10 to the 9th power. And for a second part, I have 2.025 divided by 8. I'm going to use my calculator for that. And I get 0.253 times 10 to the 9th. Let's do a check, and you can just tell this one is not written in scientific notation. Our final answer has to be in scientific notation. So we're going to make a shift. We need that decimal to move over one place to 2.53 times. All right, so this is again our thinking work. This number got 10 times bigger. So this number has to be 10 times smaller, meaning if I make one shift, my exponent has to make a change by 1. So there we go. Here's our final answer in scientific notation. Hit pause and jot this down into your notes. And that's what you're doing for the rest of today's lesson, Math Marbles. You're going to apply all the operations you've learned to answer word problems in scientific notation. Remember, once you're done with your work, please check to make sure your final answer is written appropriately in scientific notation and make any shifts that are necessary. That's it for today, Math Marbles. I hope you get a lot of practice in and a lot of feedback before your final assessment. And I will see you in the next school year. Take care.